Is Sri Shelnath, faculty, Department of CSE, BITM Ballari. So today we are here to discuss about design and analysis algorithm lab program number 5, which is MergeSort. So let's get into the topic. MergeSort using a divide and conquer. So before getting into the concept of MergeSort, let us look into what actually the concept of divide and conquer is. So already we have done this with respect to your quick sort. So again we'll have a basic idea of this divide and conquer. Divide and conquer is a problem solving strategy. So this strategy, what is actually the term strategy? Is nothing but it's approach towards solving a particular problem. So that is a strategy. A strategy term is nothing but approach or a design or how we solve a given problem. So now what is a problem in terms like, so problem could be a larger problem in size. So here the concept itself is divide and conquer kind of a thing. So we take a larger problem in existence and try to divide that given larger problem into smaller sub problems. Say suppose we have something like a larger problem could be p of size n. So wherein we are trying to divide that larger problem of p into smaller problems, say p1, p2 and so on till pn. So this is the concept of dividing. So this further, like after dividing, so we are trying to find the solutions to that smaller problems, right? A smaller problem, say p1 to pn, we are trying to find the solutions, say s1, s2 to sn. So these would be the respective solutions for problem 1, 2 till pn. So that is how we are describing this now, right? So further, so here after having all these solutions, right, so what are we supposed to do is, right, combine all these smaller units of solutions into a larger solution. So this is the means of combining or conquering. So this is a whole logic or idea behind your divide and conquer. It is as simple as that. So I can one more important aspect here about divide and conquer aspect is that we are trying to divide a problem into sub problems. That is a basic thing. So that sub problem should also be able to solve the problem which is of same type of a larger problem p. Even say suppose p1, p2 to pn, whatever the problems we have, should also be able to solve what actually the larger problem capital P is all about. So we have taken two different notations in this case, like capital P, as you can see in the previous slide, that I have denoted a larger problem in capital P and a smaller problems in lowercase or a small letter p. So for differentiation purpose, so a larger problem capital letter P, smaller problem small letter p. So similarly, like solutions also have represented in terms of lowercase letters s1 to sn, indicating that the solutions are for the smaller or sub problem actually, right? So moving it, so here this is important. One of the important things with respect to divide and conquer strategy is that we should be able to divide the problems into sub problems, wherein even the sub problems would solve the similar kind of problem. Say suppose example, I can take an example of right our engineering syllabus itself, right? So here we are dividing the entire year syllabus into 2 semesters, 2 halves first, right? So that again we are trying to divide that into say 6 subjects, theory subjects, and 2 practical subjects. So isn't it? So here, as you can see, we are trying to learn the things. So whatever the subjects you take, we are trying to learn. Even the whole year subject considered, we are supposed to learn them, attend your internals or external exams. The process is same, isn't it? So the same way we are trying to have this divide and conquer strategy. We are taking a problem, say that is a larger problem, and trying to give or divide that into smaller problems and find the solution to that, combine the final sub solutions, and come up with a larger solution. So this is all about your right divide and conquer strategy. And finally, it should also have a mechanism for combining the solutions, that is smaller solutions into a larger ones. So these are the core aspects of your divide and conquer. So here I have just tried to put up whatever we have discussed in terms of divide and conquer into a small algorithm. So whereas I've given a name as div and conquer. So that is to depict a divide and conquer algorithm kind of a thing, where P indicates the larger problem, right? So and here we are trying to solve a smaller problem. So as you can look into your a parameter of the core algorithm, that is divide and conquer with capital P. That is to say, we are taking a larger problem, so I'm trying to divide that initially, gradually, and try to come up with a solution for the smaller problems. We are not directly going and finding out the solution for the larger problem at once. We are trying to find the solutions in terms of smaller possible ways, and finally combine them. See, like, see, we have put up, like, if the problem is small, we need not like say we go on solving that problem. If not, so what we are supposed to do, apply that, right? A divide strategy. So divide the problem. So how do we divide that? Again, recursively we are trying to divide and conquer the things into smaller problems, so p1, p2, and so on. And finally, after getting the solutions for each, and there is, as discussed, a mechanism for combining. So I have to combine the solution, so s1, s2 to so on until sn. So that is how your divide and conquer strategy or algorithm is basically figured out here. So next, applying the same thing. So where is the applicability of this divide and conquer? So as you have already seen with respect to your quick sort, now we would be looking into how this could be used in your merge sort. uh, Basically, you have already done this with respect to your binary search in terms of your theory. So all these uh, uh, problems could be using your divide and conquer strategy of problem solving. So next week we'll go ahead and look into our merge sort problem, how this could be applied. Right, so merge sort. So what is a merge sort? Obviously, the name itself says it is a sorting algorithm, right? So we have say n number of unsorted elements, and we are supposed to sort them in a particular order. So that is whole idea about sorting algorithms. So what is this merge sort? What, how different it is from your previous quick sort algorithm? So here we are looking into a basic algorithm of your merge sort. So what does this merge sort algorithm do is, so it uh, takes two parameters, that is low and high. So what are these low and high? Are nothing but your uh, index values of a particular given array. So low with the point to say something like 0, high would point to something like say the n minus 1th element or the n minus 1th position, right? So here, so we are taking those two as parameters and comparing them with respect to if both are right, a particular condition wherein low less than high. So what does this condition is all about is, so as you have seen with respect to if small in terms of your divide and conquer thing, right, algorithm, the same thing. So we are trying to have this if a problem is not small, so what should be done, right? If not small, I have to go on uh, uh, dividing that into a much smaller problem. So the mid, what we are trying to do in the next immediate statement is that, so we are trying to divide your a larger problem into two halves initially, right? So mid is equal to low plus high by 2. So by 2 itself is like dividing, right? So that is what the dividing the problem into equal halves, right? So if it is a odd number of elements, you might not get the equal halves, but so we are trying to come up with a particular midpoint, right? That is the whole idea here. So that is to say, we divide the given n array of size n, right? So that is it. So next we are trying to apply the same divide and conquer strategy what we have seen here in terms of divide the problem, right? So apply divide n for p1 p2 and so on, right? Similarly is these two statements of recursive calls, right? Merge sort low mid, merge sort mid plus 1 high. So what is this low comma mid plus 1 plus high is nothing but, so low to mid will be a first half of your given array, mid plus 1 to high would be the second half of your uh, uh, divided array. So that is how. So we'll look into the pictorial representation in the next slide, but for time being look into the uh, your algorithm thing. So here what happens is, so we are trying to recursively divide your given larger problem into smaller problems. These two things, that is merge sort low to mid, merge sort mid plus 1 comma high. So these are nothing but we are trying to divide your given n number of elements into individual elements, so that would come up with, right, finding the solutions for your smaller problems, right? Then after that the last thing is nothing but a mechanism for combining, right? Combine solution 1 2 to sn, right? Similar is the case here, merge low mid high. So that is where we are trying to combine all possible solutions, that is s1 s2 till sn, and have a final solution for your larger problem. So this is how your merge sort algorithm works. So let us gradually get into a pictorial aspect of your merge sort. So here I'll be taking an example of some say 7 elements, right? So wherein 12 8 15 and so on till 2 are here array elements, unsorted array elements, and 1 to 7 are here index. So I'll just initially I have to take 2 points, that is low and high. So what you have seen in the algorithm, like if low less than high, so I need those two aspects, right? So l h, so I've just taken the l to be 1, h to be 7. So next immediate thing what would I do is, right, so I have to find that. So obviously l is 1 less than 7. So yes, so what should I do? I have to divide it. So divide it into two halves, right? So once I divide that, so I'll be getting this midpoint as m, right? So here as said, so it is a odd number of elements, so first three, and then the second half as the four elements. Why? Because as you can see, 1 plus 7 would be 8. 8 divided by 2 is 4, isn't it? So add the fourth index value, you get the midpoint. So it would divide the array into two halves at the fourth index, as you can see there, right? So here, so next thing, so what happens is, again for the given halves, I have to apply the same thing. I have to find the midpoint. So now L will be pointing to 12 and H will be pointing to 15. So I have to divide this half of your array, right? So next, let us see in the further steps how this is divided into now, right? So now, so again, even with the second step, that is L is 1, H will become, or sorry, mid will become, right, 3. So there, in terms of our algorithm, now mid will be high. So again, it will check for the same case, L less than mid. Now instead of H, it would be mid. So what is this happening in this case is, again it will become, so mid will be taking the position of H. So in this H, I have to compare the same thing. Yes, 1 less than 3. So what happens, I have to divide that again. So mid is equal to L plus H by 2, or in our context, L plus M by 2. So what happens there is, so it will be like 1 plus 3 is 4, 4 by 2 is 2. So where will it divide us in terms of your so it will take the position of second index. So I'll be able to divide 12 as one half, 8 and 15 as the second half, right? See, as you can see, right? So that happens in this case. So here in this case, so this condition will go wrong. That is, if L less than H will go wrong. Why? Because both are pointing to the same index, that is 1 and 1. So 1 less than 1, false, right? So what happens, it stops there. So that is to say that you have found a solution for a sub problem. You are trying to divide your larger problem into sub problems. Until now, once you have found a single element, right, that is a final solution for time being. That is to say, I cannot divide any further, right? This 12 is a individual element. So can I divide that individual element? No, I cannot, right? So that would become your solution 1, kind of a thing. So further applying the same strategy, taking the second half, that is 8, 15. So I have two elements, so I have to divide that again. So that will be in terms of L M, kind of a thing, or a mid plus 1, sorry, mid plus 1 to high. So the second half always will be from mid plus 1 to high. So as you can look into your algorithm, right? So the second merge sort algorithm will take mid plus 1 to high, right? The second half, what we are trying to do is 8, 15, mid plus 1 to high. The first half would be low to mid. Second half will always be from mid plus 1 to high. So this is how it happens. So for the taking this the complete thing, so we are supposed to apply the same thing recursively. So we have to divide the complete given array, that is of 7 elements, until we get individual elements. So that, after applying the same things until you get the individual solutions, would look like this. That is to say, 12, 8, 15, 7, 10, 5, 2, right? This is only a strategy where we have come up with finding the solutions. With respect to our merge sort, this is not the final solution. So this is only a partial solution for the given larger problem. So now what we are supposed to do is, we are supposed to sort them, right? And now, as we can see, the elements are still unsorted, right? So we are taking the same set of individual solutions, right? Say suppose we start from the individual elements as level 0, the next stage as level 1, the next stage as level 2, and level 3 as your final solutions. As you can see there, like initially, right, 8, 15 are in their own position. So once we move from level 0 to level 1, we look into or perform the sorting algorithms or sorting technique, right? So here as we can see 8 is less than 15, so I need not sort any elements there, so they move to the higher levels as they are. Similarly 7, 10 are in their positions, but this particular last set of two elements 5, 2 are not in their original positions, so have to be swapped. So once they move to the next level, that is level 1, they get swapped or sorted in terms of their respective positions. So for this it is the final solution, that is to say from level 0 once we move to level 1, so we are trying to combine the solution, right? So we are following now the combine aspect of your divide and conquer combining mechanism, right? So these two 5 and 2 are individual solutions. Once we combine them, so we are trying to find the solution there. So for this it is a sub problem. So once I move to the next level, that is higher level, so we are supposed to combine the solutions and get the final thing. So it is sorted, yes, obviously 2 5 are sorted only with respect to 2 5 I'm talking. It's not like all the other set of elements, only with respect to 2 5 it is sorted now, right? So similarly, so all these things are sorted, that is 8 15 7 10 are in their original positions, only 2 5 have to be sorted, so that has happened there. So next we move to the level 2, so wherein, right, 8 15 12, so we consider three elements now, right, wherein they are again unsorted, so 8 has to be sorted. So 8 is put into the first position, 12 in the second, 15 in the third. Now considering this particular three elements, or the first half of your array, so now this is sorted now, 8 12 15 are sorted. So now again taking the thing with respect to 7 10 2 5, so again as you can see 2 5 7 10 are sorted. So similarly moving ahead to your level 3, so both the halves have been sorted and finally you get the combined result, that is the sorted elements of your array. So what we have taken is 12 8 15 7 10 5 2, isn't it? So that is the unsorted array what you have say taken. So what happens is, this is your larger problem wherein you had 7 elements, so you got the solutions for your sub problems, that is individual elements as your solutions. So taking them and combining them gradually into your higher levels, we have performed your sorting. So initially moving from your 0th level to your level 1 2 and 3 and so on, so we have found the solution and finally we have the sorted array. So this is how the logic of your merge sort works, or we have applied the concept of your divide and conquer, right? So this is it. Thank you.